Custom molds are fun, and people actually buy them. Today, we're making a silicone honeycomb mold, and I'll show you what I learned along the way. Start by following the first rule of Fusion. Create a new activated component for your soap. We'll begin by modeling a digital version of the soap, then move on to designing a 3D printed mold. That mold will be used to cast our silicone mold. And as always, you'll see the keyboard shortcuts pop up in the bottom left corner throughout the project. Build your design symmetrically from the center of the origin to take full advantage of symmetry. You'll see why this matters later in the project. For this example, I'm making the soap 60 by 85 millimeters, pretty standard dimensions. Set the height to 25 millimeters if you're following along, then confirm the new body inside your soap component. Continue with the sketch on the bottom face of your soap component. Use the circumscribed polygon tool to build a honeycomb pattern. It's simple once you know a few tips. A radius of 5 millimeters from the center to the edge feels balanced for the overall soap size. Start by sketching one polygon, then add 2 guidelines using construction lines. These are just for direction. They won't be part of the final design. Fusion will snap to the midpoint of a polygon side, giving you a guideline at a 30-degree angle. In the rectangular pattern tool, the polygon is your object, and the construction lines define your directions. Set the spacing to 12 millimeters to keep 2 millimeters between each polygon. Be sure to use the symmetric option so the pattern spreads evenly across the soap. The exact quantity isn't critical, just make sure the soap is fully covered. Confirm your polygon sketch, then create a center rectangle. Turn off the construction line setting. It's probably still active from when you drew the direction arrows for the honeycomb. I'll size the box at 54 by 79 millimeters. Notice how the sketch turns from blue to black, showing it's now fully constrained. From here, extrude the honeycomb pattern down 2 millimeters. This cut will emboss the honeycomb into the silicone mold later in the workflow. Pause and orbit your model. Add chamfers to soften the sharp corners. This makes the soap nicer in the hand. It's a choice we'll test in the real world when we cast the soap. Select edges by intent. I'll put the bottom chamfers in one timeline feature and the side chamfers in another. Keeping them separate makes parametric edits simple later. Chamfers, and fillets too, aren't just about looks. They can also add strength depending on the design. For FDM printing, these details matter. In this case, the part is easy to position in the slicer first and then on the printer bed, which makes the whole design straightforward to 3D print. Great job keeping up. We've designed the soap component and we'll return to it later. Next, let's design the silicone mold. Switch to the top component before creating the silicone mold component. This keeps it at the same level in the browser instead of as a subcomponent. Sketch the silicone mold on top of the soap. Instead of redrawing, project the soap outline so changes stay linked. The mold must be larger, so I'll offset it 10 millimeters. A solid thickness for silicone. If you can go thinner without losing strength, that saves material and cost. Extrude the silicone mold so it fully covers the soap with the margin at the bottom. It's fine that the mold now encloses the soap. This is intentional. Since the real soap will be cast inside the mold, we'll handle that next. Use Combine for this step. Set the silicone mold as the target body, then press hold to pick the soap as the tool body. Choose Cut and check Keep Tool so the soap remains for later use. You won't see the result right away with both components visible. Toggle off the soap and you'll see the mold now has a clean cavity ready for casting. Great progress. Next, we'll build the 3D printed part used to cast the silicone mold. Switch to the top level in the browser and create a new component. I'll call it Mold Base. Drop your name suggestions in the comments if you can think of a better name, and let's see which one gets the most likes. Save your project now, then we'll build the mold base starting with the Surface Offset command. Use the Surface Offset tool to offset all faces of the silicone mold as the starting point for the mold base. This keeps the design parametric, so earlier changes update the mold base automatically. Use Orbit to reach all sides and set the offset to 0 mm. As with the Combine cut, turn off visibility to see the result. You now have a surface with no thickness ready to develop into the mold. Give the surface a thickness. I'll use 10 mm for a solid mold. If you find a thinner option that still works, share it in the comments. Thinner walls mean faster prints. Turn the silicone mold back on for a quick check. You'll see it fits neatly inside the 3D printed mold. With this step done, we're ready to move on to the final part. We'll keep it simple and name this component Mold Top. This part is essential for casting the silicone mold. We'll design it on top of the soap component, since the soap is needed in the casting process. Later, you'll also see how this step highlights one of the less obvious advantages of working with components. The purpose of this step is to create a way to attach the soap and mold top components to the mold base when casting the silicone mold. We'll keep the prototype simple by skipping screws. I'm over-sketching here for speed and will refine the details later in the solid modeling environment. A thickness of 5 mm is a good first estimate, balancing strength and speed. Since this is the first iteration, we can refine it later if needed. Create a copy of the part and rotate it 45 degrees. From here, it's easy to use the Extrude command to adapt all sides of the mold top to the mold base. Next, we'll add cylinders to position the mold top on the mold base with accuracy. Without them, it would be hard to align and keep the mold top in place during casting. Sketch a 5 mm circle and use dimensions to position it relative to the edge of the mold top. Fusion suggests an extrude cut by default. While we do need a hole in the mold base, we also need this cylinder. Switch the operation to new body for now, we'll come back and create the hole in the mold base later. Since we're working symmetrically around the origin, we can use the default construction planes to mirror the cylinder to the other side. Press and hold the left mouse button to select the construction plane from the pop-up menu. The mirrored cylinder appears instantly in the right place, and any updates earlier in the parametric timeline will automatically carry through. Repeat the process for the remaining 2 cylinders. While doing this, consider alternative workflows. With a symmetrical design, you could use a single sketch and apply a circular or rectangular pattern. Another option is to copy and paste the bodies into place. Choose the method that fits your style and ensures accuracy. Personally, I prefer this workflow since dimensions and mirroring make correct positioning easy to guarantee. Another tip worth reflecting on is the mouse you use. Orbiting around the model or selecting objects hidden behind others are good examples of why a mouse with at least 2 buttons and a scroll wheel makes your workflow much faster and more efficient. Now it's time to cut holes in the mold base with the Combine command. Select the 4 tool bodies, set the operation type to cut, and check Keep Tools. Turn on the visibility of the mold base and set it as the target body. Hide the mold top component to review the results. The clearance around the holes looks a bit thin, so we'll refine them further in the next step. The Offset Face command lets us push the walls outward. I'll set the offset distance to 0.5 mm, though you can go thinner depending on your nozzle size and 3D printing setup. With this small clearance, the cylinders will slide into the holes without issue. We're in the final stage of the design, and this next step is critical. We'll 3D print the soap component and the mold top together upside down because of the honeycomb pattern at the bottom. To make this printable without supports, we'll flatten the top surface. Use the project command to capture the soap's geometry. Then extrude the projection as a join operation. Before exporting, let's recap how everything fits together. The silicone mold will be used to cast the soap. To make that mold, we'll rely on the 3D printed mold top, mold base, and soap component. A section analysis is a great tool here, letting us see exactly how the parts align and work as one. Keeping the components visible shows exactly where the silicone will be poured into the 3D printed mold. The colors in the browser match the hatch colors inside the components, making it easy to read. You can leave the section analysis on while toggling visibility in the browser, then turn it off when you're done and return to it whenever needed. We'll use 2 different export workflows worth knowing. The mold base is simple. Right-click it in the browser, choose Save as Mesh, set the format to STL, and then save the file to your chosen location. The second part we'll 3D print is the soap component and mold top combined into one print. To export them as a single STL, first save your project. Then toggle on their visibility in the browser, turn off all other components, and go to the drop-down menu in the top left corner to export. Make sure to switch the file type to STL before saving it to your chosen location. It's easy to set up your 3D prints in PrusaSlicer. The mold base imports in the correct orientation, so setup is quick. I enabled ironing in the print settings to smooth out the top layer and reduce visible lines. It adds print time, but the quality is worth it. For infill, I used 15%. The mold didn't leak silicone, so there's no need to go higher. More infill only slows the print. With these settings, the estimated print time was 6 hours and 44 minutes, though it would be faster on a newer 3D printer than my original Prusa E3MK Freeze Plus, which I've had several years. Before slicing and generating G-code, flip the combined mold top and soap component upside down. I used my new preset with ironing for this part as well, which helps reduce visible lines on the 3D print, the silicone mold, and eventually on the soap. The finished soap turned out great for my first soap mold project, and there's definitely potential here for both hobbyists and small businesses. Next time, I'll place something inside the 3D printed mold to make it easier to remove the silicone without damaging the print. For the silicone and soap casting, just follow the instructions provided by your supplier. If you enjoyed this tutorial, check out my vase project. It's received hundreds of likes.